Today we're going to be talking about some linear inequalities, which is where we're going to, graph the line and then maybe do a little bit of shading. Linear inequality. But first we're going to talk about f of x, function notation, functions. So in this course, when we say f of x, we mean what happens to a number x after we do some function. So f of x is some function that takes in real numbers those are your x values, and it gives you back some other maybe if you take enough math classes later on in your life, you'll go to a course where functions will take in stuff other than real numbers and give you back stuff other than real numbers. For now, we're just talking about numbers. And these real numbers, that's going to be, what we denote f of x, or maybe sometimes just y. And one example of a nice, easy to work with function is f of x equals 2x plus 3. So that means for a given number x, we're going to multiply it by 2 and then add 3. So if they say that f of x is 2 times x plus 3, then f of 2 will equal 2 times 2 plus 3. Which is going to be 4 plus 3, which is 6. And later on in this course, we'll, start putting functions into other functions. But they're, putting. And if they say, okay, f of x equals 9, what's the value of x that makes this equation true? It's like they've given us a y value, and we're trying to trace that back to an x value. Well, we know that f of x is equal to 2x plus 3. So I'm going to substitute on f of x, and I'm going to say, well, that means that 2x plus 3 equals 9, because f of x is equal to 2x plus 3. And now I'm just going to solve for x. Okay, we might solve some inequalities with this. That's what we're doing today, is we're working with inequalities. So f of x, again, I'm going to substitute on f of x, right? I've got f of x equals 2x plus 3, so I'm going to say 2x plus 3 is greater than negative 3. So I subtract 3 from both sides, and I'll get 2x greater than negative 6, divide by 2. F of x less than or equal to 3 would work exactly the same. Okay. If they give us h of x and g of x are two different linear functions, and they ask us for what values of x is h less than g. Well, if we had a graph and we knew that, this is probably not going to be drawn to scale. Actually, no, I can. Okay, I'll draw G like that, and F, or no, H like this. Okay. And then if they're asking where is H less than G, H is going to be less than G when the y values of H are lower than the y values of G. So that would be starting here, and going on down. So that would trace back to x values in this area. we're going to do this algebraically is that we'll say, all right, I need h of x less than g of x. But I've got formulas for h of x and g of x. H of x is 3x minus 2. And so I need that to be less than what g of x is. And g of x is 5x plus 8. And I'll just solve this inequality for x. Start by subtracting 3x from both sides, so I've got negative 2 is less than 2x plus 8. I'll subtract 8. Get negative 10 is less than 2x, and then I'll divide by 2, and I'll get negative 5. So for what values of x for any x greater than negative 5? On y'all's copy, does that say 4x minus 2? Cut off. Got it. So this is f of x equals 4x minus 2. Okay, first we might look at what is the slope of x? Okay, well, this is in mx plus b form, so I'm just looking at this number. The slope equals 4. The intercepts. Well, the y-intercept is right here. That's going to be negative 2. But if I want the coordinates of it, I'll say x is 0 and y is negative 2. For the x-intercept, what I need to do is set y equals 0. But since y is f of x, I'll just say that's when f of x equals 0, and it'll be the solutions to that equation. So I need 4x minus 2 equals 0. Add 2 to both sides, divide by 4, and I'll get x equals 1. So that's x is 1/2 and y is equal. These two are both problems that we did last time, so I'm going to, in the interest of time, skip over those and deal with the inequalities right now. Okay, so if we're faced with something like y is greater than or equal to 2x plus 1, I'm going to start by graphing y equals 2x plus 1. So I'll start with graphing y equals 2x plus 1. I'm actually going to graph that in. This is pretty straightforward. Here we've got y equals 1, slope is 2, so that's kind of steep. This has the point 0, 1 on it. Maybe it also has the point, say, x is 2 and y is 5. So use that 2, 5 point here. Okay, so when we were graphing the lines last time and the time before, what we said was that the line represented the solutions to this two-variable equation. That the coordinate pair 2, 5 is a solution to the equation y equals 2x plus 1. Well, now we're looking at the inequality y is greater than or equal to 2x plus 1. So 2, 5 is a solution to that inequality by virtue of it being equal to. That's the y is greater than or equal to. But what about, say 2, 6? Does this make the inequality true? Is 6 greater than or equal to 2 times 2 plus 1? And it is, because 6 is greater than or equal to 5. So this is a solution. The point 50 is 5 greater than or equal to 2 times 0 plus 1? It is. 5 is greater than or equal to 0. Okay, so that's a point that's a solution as well. And it'll be the case that all of the points that are above this line will constitute solutions to that linear inequality. The way you can remember it is if we're looking right here at the area where y is greater than or equal to, okay, well, that we're going to take all the area where y is greater than. Where y is greater, you go farther up the y-axis. So that's why I'm going to shade over here above the line. That's how we graph the linear inequality. Okay, next we're going to look at y is less than negative 2x plus 1. Again, I'll probably, here's 1. First, I'm going to graph y equals negative 2x plus 1. And maybe I'll look at the point where, say, x is negative 1. And maybe that's, okay, so negative 2 times negative 1 is 2 plus 1 is 3. So this is negative 1, 3. Now, if I try that coordinate pair on this inequality, okay, try negative 1, 3. I plug in 3 for y and negative 1 for x. Is 3 less than negative 2 times negative 1 plus 1? No, it's not. Okay, so this is not a solution to the inequality. Okay, but anything where y is less than that, so if I just got, this was the y value here. If I got anything just a little bit less than 3, that would satisfy the inequality for x equals negative 1. So 2.9, 2.999, 2.99999, these will all be solutions to the inequality. So, do y'all remember how we dealt with this in Algebra 1, where we had the strict inequality and we were graphing? What kind of line did we write down? Yes. Yeah. Use the dotted line. Okay, so I'm going to come back through and I'm going to use a dotted line or dashed line, or whatever you call it, to indicate that, okay, these aren't solutions along this line, but everything up to them is. And again, okay, here I'm seeing where y is less than. So, think about where is y less? Y is less when you go down. Go and I shade over here. Next thing we got to do is, looks like we've got some linear inequalities that are given to you in standard form. So what I told you all about standard form, I think 2 times ago, is that what it's useful for is finding x and y intercepts. So I'm going to start by finding the x intercepts here. X-intercept we're going to find by letting y equal 0, right? That's what an x-intercept is the point where y equals 0. So I'll let y be 0, and that'll be 3x equals 4. That's x equals 4 thirds. And I'll find the y-intercept by letting x equal 0. That's what the y-intercept is. It's the point where x equals 0. So if I let x equal 0, I have 2y equals 4 and y equals 3. I'm going to graph y equals 2. And x equals 4 thirds, which is a little bit less than 2. So. And then we're going to connect them. Since I see that it's a greater than or equal to, I'll use a solid line. But if it had just been just a regular greater than, I would have needed to use a dashed line. And then I have to figure out which direction am I going to shade. Well, we can see that this is a positive 2y is greater than or equal to 4. So we can say that we're going to shade above, but why is it that we're going to do that? We're going to, if you did solve for y explicitly, you would have something like 2y is greater than or equal to negative 3x plus 4. And then if you divided both sides by 2, I'd have y is greater than or equal to negative 3 halves of x. I'm going to divide everything by 2, so I'll have 2. And here, where I have y is greater, that's where I'm going to shade where y is greater. I'll tell you right off the bat, on this next one, I see that I've got a negative y here. That might cause us some sort of issue. But we're going to attack it the same. So start by getting an x-intercept and a y-intercept. We're going to graph the line. We're going to shade above or below, depending. So I'm going to freeze it, and I'll let y'all work. I'll walk around and see if it's going right for you. And you can check your answer against me. Okay, so the thing about where we're shading, right? That was the only thing I saw going wrong when I was walking around. I saw dotted lines. I saw the intercepts going real well for us, so that's a good thing. But like, why are we shading above where it says y is less than? Okay. It's basically because if I took this equation here, I brought it down here, and I went to solve for y, I would have 2x is less than y plus 5, and then I solve for y, and I'll have 2x minus 5 is less than y. But this is really, remember the alligator eats the bigger number, this is y is greater than, so that's why we're shading up here, where y is greater than. Alright, so the next one we got is these horizontal and vertical lines. And so I'm going to, if I was to graph the line y equals 4, I'd go here where y equals 4, and it's going to be all the points where y is equal to 4, but we're looking at the points where y is less than 4. So, this point, y is less than 4, that point, y is less than 4, all these points, y is less than 4. So what we're going to do is we're going to graph y equals 4, except it's a dotted line. And since we're looking at where y is less, shade down here. And then when they say x is greater than or equal to 2, well, we know what x equals 2 looks like. That's a vertical line, right? See, we go here to where x equals 2, and we think about all the points where x equals 2. That's this line here. If I'm interested in where x is greater than 2, I'm going to shade over here where x is greater. Okay, so here I am, I'm shading, and that's the solution. Okay, the last thing we've got is, here's the inequality, write the equation. Okay, so the first thing is going to be write the equation of the line, and then figure out if it's greater than or less than. Okay, so we're going to start here with the one on the left. And we see that the y-intercept is 2 and the x-intercept is 1. So I've got an intercept. I could calculate slope, right? I could do a rise over run type situation. Looks like when we ran 1, we rose -2. So I've got slope -2, got intercept 2. So my equation with the line would be y equals -2x plus 2. Thing is, we know it's a dotted line, so it's not going to be equals. It's going to be either greater than or less than. And here I see that we're shading where y is less. Y is more negative. So I'm going to say that y is less than -2x plus 2. All right, the last one I've got, we're going to use these 2 points to write down the equation of the line, and then we're going to write the equation of the inequality. Okay, so I need a slope between these 2 points, and slope equals rise over run, so that's going to be 4 minus 3 over 1 minus -2, and that's 1. Oh, that would be 1/3, but this probably should be -3, so that's going to be 4 plus 3 is 7 over 3. That looks like what we're seeing in the picture. So what I could do is I could say y is going to equal 7/3 of x plus some b that's going to be our y-intercept. And I'll use this point 1, 4 right here. So I'll let y equal 4. And I'll say 4, well that's 12/3 is equal to 7/3 plus b, meaning b needs to equal 5/3. So since this is a solid line right here, right, I know it's going to be greater than or equal to because it's shaded above and it's a solid line. So I'm going to have y is greater than or equal to 7/3 x plus 5/3. Okay, I lied. There's one more problem I need to do. So C of m equals 1 plus 0.15 m. It's a function used to calculate the price to use a Lime scooter around Austin, where C of m is cost in dollars and m is measured in minutes. What is C of 0 in the context of this problem? What is the slope and its context in this problem? Well, C of 0, that's where the independent variable is 0. That's like the y-intercept if we were to graph this thing. And I'd say it's the cost to start renting the scooter. What is the slope? Well, the slope is equal to 0.15, and that's going to be the cost per minute. So it's going to be $0.15 per minute. How much does it cost to take a 20-minute ride? Well, that'll be C of 20, which is going to be 1 plus 0.15 times 20. That's something you can do with a calculator. George has $20 left on his debit card, and you're going to write an inequality to show how many minutes he can ride without overdrawing his card. Okay, so 20 is going to need to be less than or equal to the cost. we say 20 less than or equal to 1 plus 0.15.